Hi everyone, welcome to 10 JavaScript features you might not know about. Just want to call out to Commerce Tools, my employer. We're a sponsor at Open Source North. So if you have any time today, please come by our booth, talk to me, I'll be there the rest of the morning, and check us out. My name is James Luteric. I am a software developer who's been working in the e-commerce space for around 20 years now. I've spent a long time of that working in JavaScript with some focus on front end, and most recently I've been doing a lot of Node.js on the server side. Really love the language, so I'm excited to be talking to you guys about these new features and other JavaScript language specifics that you might not have heard of. All right, let's dive right into the first one. First one is all of the different loops in JavaScript. Now, I think most people here already know how to do a standard loop, and this is the kind of loop that we've all been doing since we learned how to program. Basic for loop, where you have a variable, you're incrementing that variable, and you've got some type of condition on when the loop should exit. So here we are looping over an array and just logging out the values of that array. So there you go, ABC. Now, JavaScript recently has a new type of loop that cleans this code up a little bit. It makes it a little easier to read, a bit shorter. And so I could say for const x of array1, and instead of logging the array with the index being passed in, I can just spit out the value because I'm iterating through the values of the array, not the index. So if I clear this and hit run, you'll see that this now spits out ABC as well. But the code's a lot shorter, it's a lot cleaner, and it's very easy to read. If you're going to run a function on every item within that array, you may also want to consider the new array.forEach method. Here you're giving it a function that can take two arguments. So I'll use an arrow function, and I will just console log out. The two arguments are the value of that array and then the index. So it's going to be ABC 0, 1, 2. If I run that, you'll see I get the two iterations of looping. So this new for of syntax allows for easier looping of that array, and then array.forEach gives you a more functional way to do things. In addition to for of, JavaScript also has a for in way to loop through objects. And here we're going to loop through the different properties in a specific object. So if I run this, you'll see we have A1, B2, C3. And here we're doing the property itself, so that's going to be ABC, and then we're using the property to get the value out of that object. So the for in statement iterates over all non-symbol enumerable properties of an object. Okay? The order of enumeration is not guaranteed. And I have seen people use this for in notation around an array, but that's discouraged as it'll include any properties added to that base array object, including any prototype functions that may have been added through a library. So it's better to use the for of for iterating it over an array, and reserve this for in for things like objects. Now what you might not realize is that this in keyword actually has some special meaning beyond just this loop. So I can go ahead and say console log and say is A in the object. So here I'm using it more as a conditional, and if I pass it, it gives me true, because A is a property of that object. So you can use that in keyword to check whether a property exists. And if we look at the compatibility of for in, this has been around for a long time. You're welcome to use this in the browser, in Node.js. There should be no exceptions here on what you can leverage. The for of is relatively newer, but it still also has good compatibility. Okay, number 2 on the list is optional chaining. So let's go through a scenario where we are reaching out to a REST endpoint and getting back JSON results. We're getting an array of items and we need to do something with that. Our manager says, hey, can you print out the name of those items? Sure, absolutely. We're going to go get the results, and we're going to use our new from/of looping mechanism and hit run, and boom, you've got that name. Now our manager comes back and says, that's awesome. Can you also print out the description for us? It's easy enough to do. We just have to say item.optionalfields.description. I run that, now I get a name and description. So we launch our code and we think everything's hunky-dory until we start getting more results. I think some of you may know where I'm going with this, but the next result is another JSON, but this one doesn't have those optional fields. It's just going to be the name. So now if I run it, we get a type error. Definitely not good. So in the past, what we would do is start adding some checks, some defensive programming, where I'll look, does it have those optional fields? If so, does it have the one I need? Go ahead, and now that I know they exist, then I can console log it. And if it doesn't exist, just got to let people know that it's undefined. Now the reason we have to do these checks is because when you immediately jump to the description, you have an undefined field, that optional fields, and you're trying to access something on an undefined. So that's your error. Can't access property on something that's undefined. So we do these checks first to make sure it's defined before continuing on. If I clear this and run it again, boom, we get the answer we want. But anyone who's worked with JSON for a while knows that this JSON nesting can get pretty deep, and these checks can get pretty crazy over time. It ends up being a lot of defensive code to check to make sure things exist. So that's where this new optional chaining comes into play. So I'll go ahead and revert my code back to the original, where I've just got 2 lines. But instead of just doing a dot and assuming the field's there, I'll use the new operator of question dot. And this is going to tell the language, hey, I know items here, but please check if optional fields exist. If not, immediately return undefined. If it does exist, let's move on to the next one and check for description. If that doesn't exist, we'll return undefined. Otherwise, grab that description. So if I run this, you get the results you'd expect. This optional chaining can definitely shorten your code, and you can use it for objects, use it with the array syntax. You can even use it for things like functions, where maybe or maybe not the object has a function. You can continue to use that question dot, where if it exists, it'll run the function. Otherwise, you're going to get that undefined. So here, this is about a year old, so it's relatively new, but there is full Babel support to get you that backwards compatibility. And if you're using Node.js 14 or higher, you can use this natively. But really, while this is green, it's only the most recent versions of the browsers that has this new optional chaining. Okay. Number 3 is nullish coalescing, which also uses the question mark. So it's a common pattern in JavaScript to use this OR operator. We use this to coalesce values because when you do this or that, it's not just returning true or false. Instead, it's going to return the first truthy value from that list. Because as long as one of them is true, the whole statement has to be true. So a lot of times we use this OR operator to be able to do things like check for existence and then use a default value instead. And that's what we're using here with this set default function. If I hit run, you'll see I'm getting a default value whenever it's null and undefined, and then string value and true in these cases. And this works really well, but there's a hidden bug depending on what the valid value should be. So if I make a few more calls here, maybe the next one's going to be false. We can also add empty string, or maybe it's an integer value. We're just going to pass in 0. Now, all of these values cast back to a falsy item, and so when I run this, they're going to get replaced by that default. But these could very well be valid values. Maybe we're trying to do some type of animation, and we want the length of time for that animation, and someone's going to want to pass in 0 so that it doesn't take any time at all and they want to skip it. So this is a valid value, and we're replacing it when we're really trying to just catch those null and undefines. So what we do is replace this OR operator with the new nullish coalescing operator, which is question mark, question mark. And now when I run this, it's only going to replace the null and undefined and leave all the other values in place. So in the future, when you're trying to do this replacement, trying to catch those null and undefined, you can use question mark instead of the two pipes representing OR. This functionality came out the same time as the last one. So again, it's your newest browsers. It's Node.js 14 or higher. We're definitely using something like Babel to support that backwards compatibility. All right. So we've all been dealing with imports for a while now, whether they're NPM packages or now importing on the web. And we're gotten familiar with this syntax of importing something from a module name. But sometimes you don't necessarily want to import it all up front. So these are static imports, and that means that the entire import is being evaluated at load time. All of that code's being pulled in and processed. And sometimes you don't need that. You'll have situations where you want to load a module conditionally. Perhaps you only need it once in a blue moon, or it's an edge case, and so you want to pull it into this if statement. If we were able to do this, that could speed up our code initially, or lower our memory usage by not pulling in that extra code. So in ES 2020, they introduced this concept of dynamic imports. And that's where you're using this import function, and you're passing it a string, and then it's going to return a promise. And this promise will give you all of those imports coming off of it. So here you can see we're awaiting the import, and then we're calling that default export from the module. And this dynamic import gives us the ability to embed it into conditionals or do other things that we can't with a static import. Like this string can now be handled dynamically. It doesn't have to be static at kickoff of code. So now with this ability to dynamically import maybe things that are created after the program's initialized or just on these conditionals, we can use this to speed up our code and improve our efficiency. Okay, so dynamic imports came out with Node 13, or a relatively recent version of the browser, or again, we're probably using Babel for this one. Next, we're going to talk about dot freeze. So here I'm using the new constants that came out a few years ago. People that have been doing this for a while know that JavaScript used to just be vars, but now we have this concept of constant, which allows us to set a value and have it remain. But here I'm setting a JSON object as my constant, and then I'm changing items within that object, and I'm going to console log it. If I run this, you'll see that the change I made worked. And to a lot of people new to programming or possibly coming from another language, this is unexpected behavior. If they see the way constants work with primitives, where if you try to change the value and run it, you get a type error. And that's what they expect with JSON objects. But you have to realize that in JavaScript, this variable isn't actually holding the data of the object, it's holding a reference to that object. So the constant's not on the object itself, but on the variable. I can show that by trying to set this to X. And here I'm actually changing the reference of JSON object. So if I run this, I get that type error that we'd expect. But what happens if you're running some functional programming, or you're just trying to be extra defensive and ensure that no one is breaking your data? You want your object to be fully immutable. What do you do then? Well, that's where we have this object.freeze. So you call object.freeze and you pass it your object. And now when I hit run, my original value will remain. I can't overwrite the values within that object. I should point out that this goes one level deep on the object, but it also works on both objects and arrays in order to make your item fully immutable. And this feature's been out in JavaScript for a very long time. It's been there from the original version of Node and some of these very low version browsers. It even existed in Internet Explorer. So you are absolutely able to use this to make your objects and arrays immutable. Hey, let's talk about the spread operator. Spread operators shown through this ... syntax, and it can be used in multiple ways. The first here, I'm using it with some arrays. I've got two arrays, just a variable, just a number, and I'm using this ... spread operator to merge them all into one final array. So if I run this, you'll see I get that final array with all of these values. So this ... breaks it up and turns it into list sub 0, list 1, list 2, and so on. It iterates over all the values of the array and spreads them out. A couple things I want to point out is that one, it will allow duplicates because the final array allows duplicate values, so that's perfectly fine. Also, that it'll maintain the order that you're putting it into. So it's going to put all of the items in list 1, then all of the items in list 2, and then the final values in that array. The next way you can use the spread operator is with objects themselves. So this can be useful in two places. For one, we can clone an object, do a shallow clone, where you take a single object and you use that spread operator to duplicate all the properties and values into a new object. So say a shallow clone, because it's only going to go one level deep, but it can be very useful for making a copy of that object. The other thing you can do is merge objects, or use that spread operator to take two objects and combine them into one, or multiple objects, as many as necessary. So before I hit run, I'll give you a moment to think about what's going to be in this final merged object. From the first two, we have an X, a Y. We also have a property called foo that goes across both of them. So what's going to be our final merged objects? With the array, we got duplicates. But here, we're only going to have one value of that foo, because when it comes to objects, you can only have one property with a single name. So you'll notice that it took the value from the second object. It gave precedence to the one later in the list. That's something to keep in mind as you start to merge objects with this ... notation. If you're pulling in a specific object and you want to override that value, you might want to put it later in the list. Here I can say foo new value. And now when I run it, it's going to take that new value. And I overwrote anything from before. And that can be a great mechanism. The final thing we can talk about with the spread operator is its use in functions. So here I have a basic function where I'm adding 3 arguments together and returning the result. And I also have an array with 3 arguments in it. Perfect. This was possible in the past to take the array and pass it into your function by using the .apply syntax. So you'd say add.apply, and that would take 2 arguments, the second one being our array. This first one is actually the reference to this that we want to use within the function. If I run this, it calls the function, passes in the 3 arguments, and boom, we get our answer. But not a lot of people are familiar with this .apply, and having to pass around to this can be annoying, maybe a little cumbersome. It's better if the language does it for us. So we can turn around and replace this with our new spread operator. I can call add ... num, and again, it's going to pass in our 3 items. I want to call out that because we only have 3 named arguments, it doesn't mean that it's not passing in all of the arguments. And I can actually go ahead and access the other ones through a keyword called arguments. So I can pass in more than what's named. Here I'll pass in 3, 4, 5, 6, 7. And notice it's still getting that 4th item, which is 6. and it can spit it out. It's just not being named to pass in. So another thing we can do the spread operator is you can actually do something like ... args, and that's going to allow you to pass in a variable number of arguments into that function without having to call on that keyword arguments, and it makes it clear that this function expects multiple arguments. And you can see that in some of the JavaScript library items. As an example, I can call to math.max, and that's going to take a variable number of arguments. And so I can go ahead and spread out my array and run it, and I get the max value in that list. Same way if I wanted to do math.min. So that is your spread operator. It came out around the same time as let and const. That was a few years ago. But if you're going to use it in the browser, you still probably want to use Babel to get that long-running support. But on Node, anything above version 5 for arrays and functions and version 8 for objects, you're good to go. Next topic is template literals, which may be one of the most useful things that have been added to the language lately. So early on, working with JavaScript and strings, we had to do a lot of string concatenation, a lot of this plus, space, and so on. And it worked, but it was very cumbersome. If I want to add more to this, I have to keep adding those pluses and spaces. If I want to do new lines, I have to deal with the /n and so on. And it's just not very clean to look at, modify, or work with. So that's why they came up with these string literals. And you set up a string literal with the backtick. And then you can just start typing your string. And when you hit a variable, you just use this $curly bracket notation, and you can have expressions within your string literals. These can be variables, these can be other operations in JavaScript. As long as the expression returns a string or something that be casted to a string, you're good to go. So if I continue this, I've got one more expression. And I got to make sure to close it with that backtick. Now when I run it, I get the same result, but my code is a lot cleaner with this backtick and these templated expressions. It's a lot easier to read, it's a lot easier to work with. And I have a feeling a lot of you are like, yes, we know this, we've been using it, we love this feature. But what you might not know about is this concept of tagged templates. Or I think of it more as a template function, where you're going to give it a function name and then immediately put your template literal right after it. And then this can call a function with a very specific set of arguments. The first argument of the list is going to be an array of strings. And these strings represent the string portions of your template literal. The next arguments are going to be all of the different expressions within your template literal. So here I have a person and a drink. If I run this, you can see, okay, I've got string 0, which is empty right now. If I make this something here and run it again, you'll see that's string 0. String 1 is this middle section, and string at index 2 is the end. And then I have my two expressions, the person and the drink. And so you can do things with these functions, with these tag templates. Now this one's pretty static, so let's go ahead and rewrite it with some of the other features we've talked about to make it more dynamic. First thing we're going to do is we're going to want to get rid of these named arguments. These templates can do any number of expressions, so our functions should work the same way. So I'll use that spread syntax to get a list of expressions. Okay. Next thing we're going to do is get rid of all of this static code. And let's go ahead and start with a return value. And then we'll have a for loop going over this array of strings. Value. Actually, we'll do it over the expressions themselves. Okay. So now we have this for loop, and we'll start building up our final string, our final return value. First thing we need to do is grab that first string portion. So we'll grab strings at index I, start at 0, and then we'll also grab the first expression, the value of that expression, and then it'll loop over and continue through the way. But you'll notice it ends with a string value, so we'll have to do one more line where we add on that last string value. Okay. And now we can return that value. Let me go ahead and console log that result so we can see what it looks like. Let it run, and great. We have exactly what we had in the last section where we were building out the string template, and I did it in a lot more code. But knowing that we can do this with a function gives us more flexibility, gives us the power to change things about how this is rendered. For example, I might want to make parts of it bold, or in this case, since we're going to the console, I'll make it uppercase. So now all of those expressions are going to be uppercase. So if I run this, you'll see James and Pepsi have both become uppercase. So these tag templates allow you to take these string literals and kind of build them in any way, shape, or form you'd like to do so. As I said, the template literals came out around the same time as constant let. Super useful, getting good support in Node 4 and some mid-level browsers. But you're still probably going to want to transpile back to make sure you've got full browser coverage as necessary. All right, let's talk about a little bit of JavaScript and scope, specifically this addition of let and const. So for one, we know that vars are scoped to functions or global. Those are the two scopes you're allowed. They also do this weird thing called hoisting, where you can define your var at any point within a function and just use it earlier on, or any point within the global scope and use it earlier on. So if I run this code is perfectly fine. Z equals 3, Z equals 5. Basically what it converts it to is the idea of this var Z up here, and then it takes out the var down there in basic terms. But now that we have new items, let and const, it kind of cleans that up and forces some better practices, where I'm going to get a reference error trying to use it before I've declared it. That's one of the benefits of these two additions. But more than that, where a var is only scoped to a function, so you can see here I have an if statement where it's trying to redeclare x and y, and if I console log them, it's printing out 2 because x and x are the same variable. It never actually changed. If I had u strict on, I'd get an error here saying I'm trying to declare it twice, or hopefully my linter would catch it. But const and let work differently in that they are scoped to these blocks. They are scoped to if statements and loops and so on. And you can see that here that you have y equals 1 and y equals 2. And I bet a lot of people have already realized this about these two additions, but what you might not know is that you don't need a conditional or a loop or anything else. All you need are these curly brackets, and you've just created a new scope block. So I can run this again and get the same result. So you can add these curly brackets anywhere you need to, create a scope block and have these new variables. You can do this within a switch statement or any place else you might find it useful. And the blocks have been around forever. The scoping came around when const and let were introduced to the language. Number 9 is a bit of a twofer. We're going to talk about both maps and sets. So in JavaScript, most items inherit from object. And so oftentimes when someone needs a map, I see them using an object for this case. And it works. You declare a new object, and you've got your keys and your values, and you're good to go. You have a map-like structure. But I think a lot of people don't realize that JavaScript has a built-in map. So I can declare a new map that's going to have optimizations for this. Now be careful, I've seen people declare a new map and then still initialize their values in this way. And that doesn't work because a map inherits from object as well, so you're just adding it to the object. And I can show that by using a map specific function where I'm going to check if it has this key. Does it have key 1? And if I run this, it says no, it doesn't, because I never actually added it to the map's data structure, that underlying data structure that the map uses. And I do this by saying m.set, and I give it a key, and I give it a value. So now when I run this, you'll see true, it does exist, and I can turn around and get that value, and you'll see that it's the map value. So there's still the key 1 on the object, but in the map data store, it's map value. So we can get rid of some of these object calls. Talk about some of the other features of a map that you get out. So one, you get to add items not just with a string as a key, but really it can be any variable here. So it can be a number, it can be an object, it can be a function. As long as it's something that you can pass in, the map can handle it. The other thing that you do get is a bunch of helper functions. From set and get, you can also quickly look up the size. You also have things like map.clear if you want to just completely clear the list at once. So if I run this, quickly got the size. So there are a bunch of benefits to doing this instead of using an object. Okay, so one, a map starts empty, whereas an object has a prototype, so it could have some default keys. And this can screw up things like your counts or cause naming conflicts within your map. Map keys, as it could be any value you want, you're not limited to just strings. Whereas objects, property can only have a string as a name. A map's keys are ordered. They're ordered in the way you add them to the map. So key 1 is always going to come before number 1 in this case. An object's order is poorly defined. Really, up until ES 2015, there was no ordering guarantee whatsoever. So there's some concerns there in using orders and objects. You can quickly do things like find the size of it, get items from it, or delete items from it as you go. And a map is fully iterable, so anything you do with iterable items, you can do with the map. But really the most important benefit is that the performance is much better. The map and the data structure underneath the map are designed to handle this type of activity. When you have things with lots of additions and removals, you're going to want to use a map because objects aren't designed for that level of adding and removing items. They're expected to be more static. So anytime you have those frequent addition removals and lots of lookups, deletes, and so on, definitely use this map data structure. Maps have been around for a long time. You've got support all the way back to Internet Explorer or the original version of Node. There should be no fear here in using maps within your code. Next one we can talk about is set. Set is also its own data structure within JavaScript. You've got a lot of the same calls as you did with map. You've got add, you have has, you have things like count and delete, and so on. And if I run this, you see it's working out just fine. So I'll change this to size, and I'll wait a second to see what you guys think this final size is going to be. Add up all the items we're adding to it, and figure out what the final size of our set is. Yeah, hopefully you guys got it right. The number's 5. A key defining factor of a set is that there are no duplicates. You know, that's how it differs from an array. The idea here is that you can only have one of each in a set. So as we go through the items we add to our set, first we add the number 1. That becomes the first entry into our set. And if I console log the size, you'll see that we have one item now. Next we have the number 5, and we're trying to add that twice. So the second one is actually skipped. If I run this here, you'll see we have 2 items within our set. because this is skipping the second one. There are no duplicates. Then we're adding a text item just to show that a set can hold multiple types of data. We're going to create a new constant called O with an object and add that in. And then the final thing we're going to add is the object itself. And you might have thought, hey, the 5 didn't get duplicated. Why is this object that's exactly the same getting duplicated? It's because this first one, we're adding the reference to the set. Again, it's that idea of a primitive versus a reference value. Whereas the second one, we're creating a new object and we're adding that to the set, or rather we're adding a reference to this new object to the set. So these are actually different items. And that's how you end up with 1, 2, 3, 4, 5 items in our set. Sets are also optimized for what they do. So anytime you need a list of items where you don't want duplicates, it's a great choice as opposed to always using an array. It's going to handle that dedupe for you. It's going to keep your code nice and clean, and you still get those great functions like clear, delete, and count to quickly work over that set. And just like maps, it is fully iterable, so you are good to go. Sets have also been in the language for a long time, so you should have no fear in adding it to your code, regardless of how you're deploying or developing. And the 10th and final item that we're going to talk about are generator functions. So normal functions in JavaScript follow a standard pattern, where when you run it, they always start at the beginning, they go to the end, and the only way to exit out of that function's execution is to either throw an exception or to error out. That's the only way out. So ES6 introduced a new way of working with functions and iterators in the form of generators, or generator functions. And a generator is a function that can stop midway and then continue from where it stopped. So it appears to be a function, but it behaves like an iterator. So imagine, if you will, that you're sitting at home, you're deep into a good book, you're all engrossed in the pages, and you hear the doorbell ring. Uber Eats is here, they have your restaurant delivery. So you get up to open the door. However, before you do that, you quickly put a bookmark in that book you've been reading, and you mentally save all the things that are going on with the plot. You go and get your food, but you immediately return back to your room, pick up that book, and pick up it and start reading immediately where you left off, as if nothing stopped at all. That, in a sense, is how a generator function works. So generator functions are created with the star syntax, and that's what indicates that it's a generator. When you call a generator function the first time, you're not going to get your return value. Instead, you're going to get a generator object. So show that, and you have your object generator. And you'll notice that this console log didn't actually execute. None of the function executed. It just initialized that generator function. Okay? So this generator object gives you a few special items that you can use. And the most important one is to be able to call .next. .next is saying, hey, execute that function. Actually do the execution. So if I run that, you'll see, boom, this will be executed first. And I'm getting an object back from that .next call. That object has 2 items on it. First, it has one called value, and that value is whatever the function yields. So here the first yield is hello. That's your value. The other thing it has is a property called done, and done is a boolean, and it's either going to be a true or false. And done will be false if there's more items for this generator function to yield. It'll be true if the generator functions hit the end and there's nothing left. I'll go ahead and add some values into this. And if I run this, you'll see, okay, I get my hello world, and then I get some undefines because we've stopped yielding. And if I call that .done again, you'll see true. Yes, we are done with this generator. We can use this to determine how many calls are left and whether I can keep calling it and keep getting yields out of that generator function. So what are some example use cases? One is maybe you need something to generate IDs. I mean, e-commerce, you need order IDs. So here we've built a little ID maker where it's got an index and I've got an infinite loop. So I can call this generator as many times as I want to, and each time it's going to yield a new value, and that value is going to increase. So if I run it, you'll see I get 0, 1, 2, 3. And in between each run, this is maintaining the context of that generator function. It's maintaining all the data within it for the next time it gets called, for that next iteration. Also want to call out that you can pass arguments into a generator. So maybe I want to give it a start value, and instead of just adding 1 every time, we're going to give it a step. Okay, and then I'll pass in 1,000 and 10. Make it look like we're generating a ton of orders. Now when I run this, I get 10, 10, 10, 20, 20, 30, so on. I can also use this in multiple places. So maybe I have 2 sites that I'm running. I've got Gen 1 and Gen 2. And for this one, we're gonna do the standard start at 1 and increment 1. So I can go ahead and make this Gen 2. And now when I run it, you'll see I have 2 versions, and both of them are maintaining their state, they're maintaining their variables, and they're just yielding those values as they come out. So generator functions came out with ES6, so you are not safe to use it in a browser yet, but you are able to use it in Node.js as long as you're using version 6. So what's a good top 10 list without a bonus item? You always need that 11th item to make sure that the title was lying. And my bonus item here is one of the coolest things I think you can do with JavaScript, and that is mouse trails. No, in all seriousness, when I started doing JavaScript development, this is the kind of stuff we would love to do, because JavaScript was able to add a flashy element to your website. But I think as a result, it was often made fun of and ridiculed by developers as saying not a real language, it's just a scripting language. It's existed for 25 years now. It was released back in 1996. But over the last 25 years, it's still the best way to run code within a browser. And so many JavaScript killers have come and gone, whether it was Flash or Dart, compiling another language to JavaScript. Heck, when WebAssembly came out, everyone told me it was going to completely replace JavaScript in 5 years. It came out in 2015. I'll give them some more time. But instead of dying, JavaScript continues to expand. It's in the server with Node.js. It's made it to mobile with React Native. And so my last bonus item is I just want to call out that I love JavaScript. I feel like it can do anything at this point. I've seen people do machine learning in JavaScript. I wrote this entire presentation in JavaScript to run in the browser. At this point, JavaScript can be your only programming language across the entire stack. And tools like Babel make it so you can use the latest feature of the language. And let's be honest, over the last 25 years, the language has gotten really good. It's improved from its early days. But with that said, it's also maintained full backwards compatibility. If you open up 25-year-old code in a modern browser, it's still going to work the way you'd expect. I don't think any other language can make that claim. Java code from 25 years ago is not going to run on the current JVM. You need to match the execution environment to the code language itself. So JavaScript is amazing, and it's come a long way, and it keeps getting better. So I want to thank you for coming to my talk today. I really appreciate it. And as I said, I'll be over at the Commerce Tools booth, so if you have any questions, if you just want to debate languages with me, if you want to talk e-commerce, I'm there. I'm ready to have it out with you. I also plan to put a version of this talk on YouTube, so if you missed it or have other people that you'd like to share it with, please go ahead and head over to my YouTube to find it. It should be posted within a few days. Thank you so much. I appreciate your time and enjoy the rest of the conference.